Number 5 gives us the following function, x to the fourth minus 2x cubed, and they want to know which of the statements that they give is true. So to do that, we need to look at the first and second derivatives. So the first derivative, let me switch colors here. The first derivative is going to be 4x cubed minus 6x squared, and we're going to set that equal to 0. And then we can factor out a 2x squared, which will leave 2x minus 3. And setting each factor equal to 0, so either x is 0 or 3 halves. Alright, then let's come over here and do our line analysis on the first derivative. So here's 0, here's 3 halves, and let me switch to red. So if I pick -1, say, and plug it into the factored form, let's see, if you plug in -1 into 2x squared, you're going to get a positive 2. We really only care that it's positive, though. We don't care about the actual number. Plug in -1 into 2x minus 3, and you're going to get -5, or just negative. And a positive times a negative is negative. Okay. Let's say you pick a positive 1. Well, then you would get a positive, and let's see, 2 minus 3, negative. So negative, so overall answer is negative. And if you plug in 3 halves, say you plug in 2. Well, then you're going to get a positive 8. And a positive 1, so positive result overall. Alright, so if you think of your first derivative in terms of slope, that means we're decreasing, still decreasing. We're going to level out for a moment here, though, and then you're going to be increasing. Okay, now for the second derivative. Let me switch. Oops, one moment. Let me switch back to black here. F double prime. So I'm going to go back to this part, the 4x cubed minus 6x squared. Take the derivative of that, so that's going to be 12x squared minus 12x. Set that equal to 0. And if I factor out a 12x, that will leave me x minus 1. So either x is 0 or x is 1. Alright, let's come over here and do the line analysis again. And let's line it up. So here's 0, and here's 1. And let's see, I'm going to mark in blue the 3 halves. Okay, it's not a critical point for the second derivative, but I just want to mark it and keep everything in line with my first line analysis. Alright, now let me go back to red. Alright, so if I pick -1 and plug it into the factored form, I'm going to get a negative times a negative, or positive. If I pick a half, I'm going to get a positive and a negative, so negative. And if I pick 2, I'm going to get a positive and a positive. So positive. Okay, so this means that it is concave up, concave down, and concave up. Alright, so putting those pieces of information together, let me switch to green. And let's see. So I'm going down, but I need to be concave up. And then I'm still going down, but I need to be concave down. Okay. And then at 3 halves, I need to go back up. Okay, so between here and here, I am concave down. Between here and here, I'm concave up. Let's see, I'm concave up. Okay, so my graph, so the green is a rough sketch of the graph of what we want it to look like. So now, so the graph has one inflection point. Let me switch to blue, which is going to be here. That's my inflection point. And 2 points of inflection. I also have another inflection point here at 1. Okay, so I have 2 points of inflection, and the function has one relative at extrema, which is going to be down here at 3 halves. Okay, so we want C.